Hey, this is Mr. Warden. I want to address the big question. What is a system of equations? I'm going to start this off by talking about that monster truck rally that you organized. You may not remember organizing this monster truck rally. That's probably because it's in the future. But when you organized that monster truck rally, you decided to charge $25 for adult tickets and $12 for kids' tickets. And you ended up making $13,600 from your ticket sales on the 700 tickets you sold. So this is a classic example that sets up what's called a system of equations. Now I'm going to scroll down here a little bit. A system of equations is two or more equations that we can consider together. Now, of course, a solution to a system of equations is a set of values that makes all the parts of that system true. Basically, it's a set of xy values that would make both or all equations in a system true. So, the trick in this situation with your monster truck rally is to come up with a couple of equations and then use one of the tools of systems of equations to figure out what values would make both equations true. Basically, what xy point would be on both lines. So let's first look at this situation. You might notice that there are two rates here. So there's $25 per adult and $12 per kid. And if we multiply that $25 times, say, X adults and the $12 times Y kids, you would get a total amount of money made from ticket sales. Okay, and the total amount of money is $13,600. So we can create ourselves a nice little standard form equation. We can say 25x plus 12y equals 13,600. And you won't see anything on the graph because it's way off there, up in the way up there in the first quadrant. All right, now, but what you might not realize is there's a second equation hidden in this. Now, this is a sneaky one. Now, let's just read through. So remember that the monster truck rally, okay, you sold tickets for $25 for adults and $12 for kids. You ended up making $13,600 from the ticket sales on the 700 tickets you sold. Now, this sentence right here reveals a very simple equation. Adult tickets versus kid tickets. And since I've designated X to be adult tickets and Y to be kid tickets, we can just make a really simple equation to say X, adult tickets, plus Y, kids tickets, equals 700 tickets. Because that's how many tickets we sold overall. And we don't know how many are adults and how many are kids, but we do know we sold 700. Now we have two equations that we can work with. Now I'm going to zoom back out so I can manipulate this graph a little bit. We're going to go out there. So the thing is, the number of tickets sold, there's this equation. This is the total tickets sold. And this equation is like, how much money did you make from tickets? You call it the revenue equation. Makes two lines. It makes this line here. That's the 700 tickets that were sold, adult tickets plus kids tickets. And this equation, which is the revenue equation, $25 per ticket times adults plus $12 per ticket times kids equals $13,600. And so we've got these two equations. You might notice something about these equations and these lines. They intersect. The intersecting point is a place that both equations share. And that place that both equations share is a solution for this. And if I click on that, you can see that it's 400, 300. So X is 400 and Y is 300. What that tells me is that there were, I'm going to type the solution here, 400, 300. That tells me that there were 400 adult tickets sold and 300 kids tickets sold. And we can plug those numbers in. That is the solution to this system. We have a way of knowing how many tickets were sold since we have two equations to work with. Now, if I do 25 times 400 plus 12 times 300, I do get 13,600. And if I do 400 for X plus 300 for Y, I get 700. What that means is this point makes both equations true. It keeps that equal sign a true equal sign. And so this is a solution to this system. So there's other systems we could look at. Now, this is one of the methods for solving a system. It's called graphing, solving a system by graphing. Okay. So there are several other ways to solve systems. There's solving systems by something called substitution. There's solving systems by something called elimination. And those are the three basic types that we're going to focus on. There's some others there's a couple of other methods that will be exceeding options for you on this. There's something called the Kramer method using something called a matrix. If you've done Russian School of Math, you might have come across matrices at some point. But we're going to focus on three basic methods: solving systems, graphing, solving. Oops, I should do this like that. Solving systems by substitution, which is what level 3 is about, and solving systems by elimination, which is what level 4A and 4B are about. Levels 1 and 2 are about graphing. Level 1 is about graphing and solving equations. But as you might have noticed, level 7, I taught you a bit on how to graph linear inequalities. We can also have systems of inequality. So I'm going to change this to an inequality. Let's say we wanted to make we wanted to make more than $13,600. I can create that as an inequality. And I'll bring this up here. We want to sell more than 700 tickets. So if that's the case, then anywhere in here, notice I've got two inequalities. They're shading different areas. So this inequality shades here, this inequality shades here, and there's an overlap zone that tells me that if I sell 700 more than 700 tickets, and I'm going to, these are all the situations, the numbers of tickets that I could sell that would get me more than $13,600. Now, what if I knew I was going to sell less than 700 tickets? If that's the case, if I want to make more than $13,600, this sliver here is going to be the solution. So the overlap is, in both cases, it's an overlap. With an equation, it's a single point. With it's an inequality, it's sort of a zone of overlap for the solution. So systems of equations are going to be looking for the overlap in some way or intersection between a couple of equations or a couple of inequalities. This zone is an intersection of inequalities. If I turn them back into equations, then that point right there is an intersection or overlap of just the lines. And that's a solution too. And I'm going to stop. I'll be making a few more videos on all of this, and I hope this gave you a little bit of an introduction into